The most simple pattern is the type pattern. This will perform a runtime check to determine which type it is. This is useful in many cases. One example is to check if you are working with a specific subclass. Depending on what you match on, the type patterns may not even have to be related to each other. Consider this code snippet, where you have an object, and you may want to determine which type this is. You can then add a few patterns. For example, you can ask if it's an integer, string, decimal, or really any type that you'd like. Most of the times, you'd be working with a shared base type or have a constraint on a generic type. When it comes to generics, the compiler does not take the generic constraint into account. That is why you'd be able to add a type pattern for integer, string, or any other types that aren't really applicable to the constrained type. If you use a concrete type, a base class for example, the compiler would produce an error if the pattern is not applicable in this instance. The type pattern is extremely useful. Consider if we'd introduce a subclass of the order that represents a cancelled or a shipped order. The type pattern will also ensure that you have an instance of what you want to match. If it's null, it wouldn't be a match. Which makes sense because it looks at the runtime type of the instance. You can capture the value as a local variable with the correct type. That is the declaration pattern. We can modify the calculation of the freight cost to give this a try. The first pattern expressed in this switch expression first checks the type using a type pattern. Then it applies a nested pattern to check a property value. If we'd like to capture this as a local variable that we can use in the expression, we'd simply write the variable name. Let's call it provider. We can then use this inside the expression as the concrete type. If we hover the provider, we can see that this is the Swedish Postal Service shipping provider. To make the code a bit more interesting, we'll use the property freight cost on the provider and add an additional cost if you've asked for next day shipping. For all the other instances of this shipping provider, hence all the instances that do not express next day delivery, they'll get a bit of a discount. For the default case, this is all the other shipping providers. How do we access them inside this expression? We can't use the discard pattern, because discard means that we don't care about the value. This is where we can introduce the var pattern. The var pattern, much like the discard, will match on everything, but it is slightly different. It will allow you to capture the variable that was used in this switch expression, and then you can use it in the default expression. Why is this useful? And why not just use order.shippingProvider? Well, consider the case where that call could be expensive or perform some computation. Doing that again could have some performance impact. The var pattern will capture everything that is not caught by the patterns above. This is just like the default case. You've now seen how to use the type pattern, declaration pattern, and var pattern.